Please welcome panel moderator, Growth Strategy Leader, GE Additive, Greg Morris.
Well, I guess go ahead and have a seat here. And welcome back from lunch, everybody, and thank you for joining our panel here as we talk a little bit about industrialization. First thing I'd like to do is to go ahead and introduce to you the panelists that are joining me up here on stage. So to my immediate left is Rich Baker, who is the CTO of Protolabs. Florian Maher is the business unit head of Additive within Oerlikon, and Paul Thiele with Roush, vice president with Roush. So I think what we can do first is let each of these gentlemen give you a brief explanation of their company, try to frame what their activities in Additive will be under the larger umbrella of their companies that they're working for. So Rich, if you wouldn't mind going ahead and tell us a little bit about Protolabs.
Sure. Protolabs, we're a fully digital manufacturer. We got into, started as a digital company selling online parts, and we expanded into additive through acquisition. So we acquired a couple companies that were leaders in quality of additive manufacturing. So it was a natural progression from taking parts in over the internet and selling to any engineer that had a credit card. So even if you haven't heard of Protolabs, probably your engineers have, and certainly the Snap generation knows of us if they're in FIRST robotics and these sort of things.
Great.
Sure,
Yeah.
thanks. So Oerlikon is a 3 billion little nice Swiss-based company. We do make everything around material processing, as we call it. So as Michael said earlier on, also a coating is an additive solution. So we add material, give it a function. So far, if I'm a bit arrogant and tease my colleagues, then we decided to not stay so superficial. Now we go in the substance and build the structures, because that's what in the end additive does. So you just apply material into a 3D and give it a function. And beyond this, we make also material processing for polymers, so for textiles. I do love the future of that. We're going to print textiles. Honestly speaking, that's probably a long future. So I think a lot still will be weaved and stuff. But we make those man-made fibers, as we call them, so polyamides and stuff like this, and we make the machines for this. And we have a division called Drive Systems, which makes off-highway drive systems.
Thank you. Paul.
Okay, well, thanks for inviting me. I appreciate the opportunity to talk to everybody. Roush Industries is a very diverse company. You may be familiar with us as Roush Fenway Racing, our NASCAR teams, but I'm in the engineering services and testing and manufacturing part of the company. We're very diverse. We are located in Detroit, Michigan, so our primary customer base is automotive, but we do a lot of work with the aerospace industries, also amusement park ride systems. Our company is heavily involved with design and manufacturing. Of course, there's an analysis part of that. And then recently we've been getting involved with more and more the additive manufacturing and rapid prototyping. But we cover a lot of different bases, a lot of different customers, primarily OEM in the automotive space, and the ones you're very familiar with, and a lot of the ones you're hearing about from a disruptive standpoint, from the electric vehicle and autonomous vehicle standpoint.
Great. All right. Well, thank you guys for giving us that high-level overview. So, look, as we go through the questions that I have a few I'd like to pose to the panelists, but really, I'd love this to have some questions coming from the audience. So those of you who may be considering jumping into additive more deeply or just jumping in, period, it would be very helpful if you would like to ask these three gentlemen questions. We would love to take questions from the audience. So Krista and Leslie will be walking around with mics. So if you have a question, it's going to be a little tough for us to see you due to the lights on our eyes, but just raise your hand and one of them will come and give you a mic and you can ask the question, all right? So let me just kind of dig in a little bit deeper. When you guys started to consider additive, and again, each of your companies have a slightly different background, if you will. for instance, Rich, I know that Rob Connolly was the company, and Fine Line was the company that you acquired that had been doing additive, and in particular, I think, a lot of polymers, although you've since gotten involved in metals. So, why did you guys get involved in additive? And what was the impetus to say, now's a good time and we want to more fully explore this space? And in particular, maybe with a focus on metals, although not exclusively, of course.
Sure. Well, as a service bureau, we came from injection molding and CNC. And so we're focused on delivering speed and prototypes as well as low volume manufacturing. So from a prototyping standpoint, stereolithography is a really natural fit, and that was a real strength for Fine Line. But when we look at the other things that we do on the machining side and other things, almost every part in metal requires some level of machining. So there's a natural fit there as well. And we also have moved into more of the low volume on-demand manufacturing. And we see that's where a lot of metals will go, where you want to both prototype and produce, at least initially, probably with a service bureau.
So that's actually a great point. You say low volume, and low volume is in the eye of the beholder in some ways. Right. So I know with your CNC stuff, you can do low volume, but you can also do thousands of parts. Do you find the same in additive, or do you find that low volume to you is under, say, 1,000 parts type?
Well, there's a crossover point with that tyranny of injection molding, which isn't a tyranny for us, because we have a crossover point that's usually between 500 and 1,000, where it makes sense to go to the extra step and actually design for molding. With some of the newer technology, some polymers particularly, we can do thousands cost effectively.
Okay, great. So we'll just go down the line on this one.
Sure. So first, let me say, what do we do in additive? So we make the materials, so we atomize them. I don't know why it's called atomization. I'm an engineer, it's not an atom, but it sounds cool. So you basically blow air and have little powders. And actually that history is quite long. So since a long time we have made thermospray powders, and actually we have been wondering why one particular customer, and I think I can say that's public knowledge, MTU, they ordered a 718 Inconel steel in a kind of weird size. And we didn't really know what that's for, and found out they're actually not thermospraying, they're using it as some strange process called additive manufacturing. So this is how the company actually came into making those materials. And then at 2015 we decided that that's now has reached a point where for us as a company it makes sense to get fully engaged into it. And with a lot of support from the board, as you saw Michael this morning, that I think we come to this, one of the challenges, you need to have some breadth of investment and you need to be serious about going into it. Then we decided we also want to make engineering and production of components, and we looked around. Greg was already part of a bigger family. I don't know if you realize Greg Morris being the hero of the industry, for those of you who don't know him. He's the pioneer, so I'm very honored. So we are 3 years into this business now, sitting with Greg on a panel, so that's kind of a cool ramp up for Oerlikon. So we had been as smart and thought, let's buy a company. So we bought a very good company in Germany and America, Sitem. So we picked up 10, 15 years of additive experience, basically doing something very similar. Like you guys, and now here we stand. So we come from the material side, and we do all the engineering onto the final component.
And post-machining as well?
And we do our post-processing, so whole heat treatment cycle design, CNC machining, and then in the future, I mean, there's so far not so many applications, but we have some R&D studies. Obviously, we look actively for printing and coating components, which can be a very nice combination, because then you have both technologies, which will be the future anyway. I mean, additive, and I hear those, yes, things will be printed, but we actually have a different philosophy a bit. We think it will be an integrated production step into other things, and a lot will be just a combination of other production steps, and then you get the real benefits, and not just having everything out of one machine, but having it combined with a coating or with some other bonding or whatever technology, and then being part of a more complex system.
Okay, great. Yeah, Paul.
Yeah, so at Roush, we started, bought our first SLA machine over 20 years ago. And we bought that because at the time we were doing a lot of design, and we're doing a lot of machining of parts, and our customers really wanted to have parts quicker. And some of the validation we needed to do, the SLA was perfect. We could put those on engines even, on some of the cold side of the engine, and actually get performance parameters off of these new designs before actually going to any kind of tooling. So that's kind of how we got started in that. Of course, that evolved into using the SLAs for vacuum mold patterns, and it just grew from there. And over the years, we've expanded into SLS and FDM. We've got a variety of different machines and different materials now that we can use. Again, primarily was rapid prototyping kind of thinking. Back in 2016, we bought our first metal machine, aluminum. And that went really, really well. And just last month, we've commissioned the Concept Laser 2000 machine. So now we've got a large build bed, and we're running aluminum powder in that also. And our real interest in that is we've got a customer, an aerospace customer, that needed a large build volume to build their actual part. It's an engine block for space applications. And with that, now we're going to be able to start growing that and building those in enough volume and enough capacity to meet their needs. And we're seeing that as kind of springboarding into some of the other industries that we're working with too, to be able to utilize that technology where the volume makes sense and where the value makes sense.
So that's actually a good segue into another question I have, which is, what's the profile of your customers? It sounds like aerospace. I think Roush. I think automotive, of course. Internal, external.
Yeah, we're heavily automotive based. Probably 80% of our business, our customers are automotive based. And we use the additive tools to support our own internal programs where we need to develop and demonstrate to our customers that our design functions properly and meets all the performance parameters. So we do a lot of prototype automotive builds of not only vehicles, but engine systems and components. So we utilize it for that. Aerospace is another application, another industry that we're heavily involved with, and supporting a lot of the different structures that are required for that. And again, we're doing design for that. And then probably the third biggest industry for us is amusement park ride systems. We do complete design and manufacturing and build of those systems. And as you know, that's low volume, so it really perfectly fits into the growing the 3D parts for that. So we leverage that quite a bit. And even in some of our automotive applications where it's prototype builds, where we're working on a fleet of 100 autonomous vehicles right now where they need FDM parts. So we're utilizing the tools to create those parts in a quick way without having to go off to get injection mold tooling done.
That's great. Florian, same question, I guess. Your market is pretty varied. It's a variety of different industries, or you have focuses on certain industries?
Yes, we do. I mean, the majority of the business currently we do as the whole industry, there's 80% is around prototyping business, and actually mainly for the automotive industry, where there's a lot of R&D work goes on functional prototypes, which is interesting because they're very demanding parts. So that's good to challenge also the technology. The second big field is we do a lot in aerospace, which is also a given because the price point in aerospace is the highest. I think we come to this. A lot is driven for the penetration, is driven by the costs, as lame as it sounds, but if the costs for a part are more than the whole system is. So aerospace is a very suited industry because it has the highest price point position, highest value and those type of things. And we just recently stepped into making serious parts into aerospace, so we currently have flying parts that are on non-commercial, and we now go in commercial. I think it's known that we work closely with Boeing and those topics also to go into those fields. So these are our clear two main industry, automotive and aerospace. And then for sure power in this time is a bit in a difficult overall economic situation, so the whole industry is a bit in a resorting phase, but we do have quite a series of interesting projects with particularly the second tier of those manufacturers. So I would say these are the three. Future, we also go into medical as a specific, because actually the demands on the parts are quite similar to aerospace parts. I mean, you want to have 100% quality on an aerospace part, you probably also want to have 101% on a medical part, because that's critical. I mean, you also want to have a 100% quality on an automotive part, but if it fails in 1,000, if you have one failure in 1,000,000, and if this car stops, it's not as critical as in your body and stuff like this. So from a quality system point of view, engineering, qualification, medical, as strange as it sounds, medical and aerospace are actually quite similar. So to run it as a business system, because it comes with a lot of cost to run it, that makes a lot of sense to have those verticals somehow connected.
Yep, I totally agree. And same for Protolabs?
So Protolabs, we have a really broad customer base. We had served about 18,000 different engineers that uploaded parts in the first quarter. And last year we served 15,000 different companies. So we're really focused on that digital delivery and the supply chain side of speeding up their development process, their research and development cycles, how we make those faster. No segment is more than about 25%. I think the largest is medical for us. Medical device is a really good segment, and surgical equipment. Again, just speeding up. There's so many of those companies. The other ones are spread through, and the ones you mentioned are also quite strong for us, especially on the metal side.
Yep.
It seems like the satellite, we heard some of the things about a lot of people doing different things there with satellites, and the cost for parts and the lightweighting benefit is so strong. That's another one that's pretty strong for us.
So I think a common theme with all three of you is that you play in highly regulated industries, which speaks to that quality you were talking about, Florian. In order to achieve additive really getting ingrained with some of these companies, I'm curious, within your own organizations, what were some of the barriers that you may have had? Maybe not. Maybe the orgs were all in on additive right from the beginning. But more importantly, what have you noticed with customers or others that are out there kind of thinking about additive? What are some of the barriers, the reasons that you hear why there might be some resistance to more fully adopting the technology? Some perhaps very valid, and others maybe just misconceptions. Whomever wants to grab that first.
Without mentioning any names, it seems like the quality groups tend to be really stuck in the way they do things today. So you don't have the same, we're doing metallurgy in some cases in the process. And how you know that you've got the quality of the part and the way that they'd like to certify that has to change. Also from a digital standpoint, trying to get them into the digital age, they're used to doing everything in a way that assumes you're gonna have a certification on the material you started with. So they've kind of built in the idea of subtractive manufacturing into the quality system, and you have to go undo that or convince them that your parts are actually qualified and you're going to be making consistent things. So we've had to come up with ways to do standardized witness parts for all their initial builds to convince them and to build that data set. Even though we've done it for other customers, and someone was talking about that earlier, at what point can we get to a point where we know the quality coming off the machine and people are willing to accept that for their designs and for their analysis as well as for final parts? So I think that's one of those challenges.
Yep, totally agree.
Yes.
You guys have,
Yeah, fully agree. On certification of thought, I mean, the development that we currently see and drive a lot is to go from single part qualification, which is very, very time consuming, but you have to do it, to process qualification. That takes time, takes 24 months or something like this. A lot of prints, thousands of prints. What we do see is that the machine-to-machine variation is still much too high. I think today was already announced that some of the machines are, you see where they're coming from an R&D environment. If we are machine builders ourselves, and if you look into it, and now with you guys and other industrial companies stepping into the field, you come with a different view on it. Like how you build the system. It's still the inner frame looks like an R&D machine. I can look at it, I know the precision of this when the sun is coming out is different than when or on an ARCA machine. I mean, if a forklifter drove by, then the E-beam went all over the place. So you see it, you need to shield it. You know this from the beginning. Yes, it prints, but in an industrial environment, you want to have 100% quality, and you need to eliminate this. That comes with different machine concepts. The costs have to go down. I'm sorry to bother on this. If Tom Glynn is here, so the cost of the machines have to come down dramatically. And yes, the material costs, I know, also have to come down, which brings me to a point. So this is an R&D topic between material guys and machine guys, because we need to match the window of the material and the process window, because so far we throw all the good stuff away. And this focus will come now. I think the industry work on this industrialization, and we get the cost to a level where a lot of applications make sense.
Yeah, so if I just interject, because Paul, I'm sure you have a comment or two there too, but on cost, I would agree, costs need to come down. I think the way, and I'm sure you would agree, that I have tended to think about it is the unit cost needs to be lower.
You need to look
so,
at the whole
I don't care if it's a $10 million machine, as long as my unit cost is so fast it produces the widgets at the cost that competes against, say, more traditional methodologies. But Regardless, I wholeheartedly agree. I think that's a big barrier to adoption as people look at the technology and they think, oh, this is very costly, maybe rooted in some ignorance of how you can take a design, go from part level to system level thinking. But regardless, that has to change before we see a huge spike. Did you want to add anything, Paul?
Just briefly, I agree with Rich and Florian here in terms of the issues they brought up. And it really depends on the industry you're talking about, who that end customer is. The aerospace has concerns and there's limitations based on that industry. Automotive, it is purely driven by cost. And even in the automotive industry, they're not familiar with it. So talking to them, and one thing we have done a lot is to educate our customer in designing for additive. Because it is a different mindset, as we've heard this morning, a lot of people talking about that. But that, I think, is a limitation too, and knowing what to do and what can you do. But it really comes down to what is the throughput on the machine and what does that part really cost. That's what would really drive you into using it more.
Yep. So let me pause and see if anybody does have any questions for our panelists at the moment. So I think I see someone right here in the third row. If we can get a mic over there, that'd be fantastic.
Hi, Jill Vanderwestein from Corning. This is a question, I think from Poder Labs, you mentioned that the quality architecture of current products is somewhat based on the fabrication technologies made, that's used to make those products. So how do you get over that hurdle to help people who've been doing something the same way for, a long time to say, oh yeah, you can do it this other way too, and it still works, without them saying, trying to argue physics with you?
So there isn't one magic bullet on this one at all, especially on the metal side. And as I said, but the level of qualification and whether you need to hip hot isostatic press parts and things like that, those are all the studies that I think have been done. Having a method to show that qualification that's occurred in the past and a way to get through a reasonable number of tests quickly to confirm, as opposed to generate from first principles, the quality. So we have agreed to work with GE on this. They have some capabilities from AdWork, so I'm going to put a little plug in for them. From a consulting side, they've probably done more to qualify the process than I think anyone else, because they care so much about fatigue and over temperature cycles. So I think that's one thing, is have a clean program that you can execute in a matter of weeks, as opposed to blowing up the cost, because you're confirming you're not, but getting people to believe that. And the way we've gotten in with that has been by focusing on the R&D side of it, and then they sort of drag the quality groups along because they can't get parts anywhere near as fast as from a service bureau, and they're not going to invest in all of the equipment and the facilities if they haven't seen that it's going to produce quality for them. So I think being on that front end has really helped get exceptions to the normal process.
Florian, Paul, do you want to add on that?
Yeah, adding one idea, as you said, I mean, there's a lot of engineering that goes into it, and we have achieved as an industry quite some quality steps recently. One aspect that I would bring in is to look at the entire value chain of it. So it's not only in the printing process and to see what falls off the printer. You can spend your whole year and life on it to get that right. But a lot you can then actually heal in the hipping process afterwards, or other post-processing, or you need to start early on in the material design. Yeah. So otherwise, if you have the wrong specs in the material side of it, you can call it Hastelloy X. For those of you who don't know, it's a very sensitive material. There are 80,000 variations of Hastelloy X. They're all in the spec of Hastelloy X. Hastelloy X cracks. So you don't like cracks because at some point you have fatigue, it will fall apart. Now, to find the right alloy combination of Hastelloy X that actually is crack-free, and we run some computational design on it, we found 10 out of 80,000. So some issues you start very early on in the alloy design or redesign, some you do in the process parameters itself, or some you even do in the combination later with a hip where you compress it, or all of the above. Right. And then you're going to solve quality and performance, and by the way, cost improvements also. So. Yep. I
Paul,
don't.
do you want to add anything? Or?
Yeah, just another little point. I mean, there is no replacement for doing all the hard work. I wish it was easy. You just push the button, and yeah, we've run this material before, and it's going to work flawlessly for you. But it does take development uptime, research, if you want to call it that, to validate the process and make sure it's consistent. And monitoring the machines as it's running is really important as well, because once you have a process defined and a set of parameters, you need to make sure that machine's doing what it's supposed to do.
So I think, do we have another question? Oh, great. Yeah.
Yeah, Ralph Resnick with America Makes. I guess to follow on to what Florian was just saying, in traditional manufacturing, we see material suppliers developing the materials, and we see machine manufacturers focusing on machines and tooling guys focusing on tooling. If we look at historically in the additive manufacturing world, it's been a company that is doing everything, the material development, the machine development, and so on. Do you think it's critical for us to move the industry forward that there be a separation of these duties, and that, or is the process just so intrinsically connected that one company has to be engaged in all aspects of the process?
Sure.
Good question.
Well, did you ask me or you?
All three of you guys, go ahead. Go jump in.
I would definitely say from an engineering point of view, you need to look at them all together. How you organize it, I mean, that's a bit, from training, I'm an economist also, so the different ways how the world is organized. You can organize by hierarchy, it's called a company, or you organize by market forces. I think the solution will be in the middle, because having one company that runs it all, it tends to design a closed system. I don't want to mention our major communication device system, but there's a closed system out there, and that works nicely, right? I do think it limits it, so I think you need some open interfaces. So we really believe also in the value of those partnerships where we're quite happy to work with, where we bring in some things, other parties bring in other things. But you also need, and that is against, and Michael said this also earlier on, sometimes you also need to fight yourself or keep yourself back against building competitive advantages, because in the end it limits the industry. And we do need to have some standards and some openness, because then the whole industry can grow. If I develop a material, that only works on a concept laser machine but doesn't work on any other machines, great for this closed system. But if I have some standards that it also works on other machines and vice versa, I think in the end we do the industry better benefit. So I would say it's a combination of both.
So I would just add in that we do not use just materials that have been developed by the machine manufacturer. So today there are plenty of second outside suppliers that are producing powders and producing materials for this. Carbon is one that's a closed system, but there are good reasons for that. So I think it's going to depend on which technology we're talking about. On the polymer side, where you're actually doing polymerization, you have to actually test every batch that's coming, and you have to adjust the process for it. And that's going to keep that a closed system. But on the metal side and on the more general polymers, there's room for a lot of innovation. There are a lot of companies going into that space already, which I think is really healthy. And certainly for the binder jet, you're going to open up all of the materials that are available to metal injection molding. So that's going to be a completely different ballgame there as well.
And I think it's going to evolve over time. Of course, being a closed system, you know what you're going to get, but sometimes you need to stretch the envelope a little bit, and that's going to require looking at different polymers and different metals, different powder suppliers, or parameter set development. We've gotten involved with some new materials, some carbon-filled nylon, and there was no parameter set developed for this FDM machine, so we did all that ourselves. Took some time, but I think it just depends on which specific product you're looking at, what particular machine, and what you're trying to do in the end.
Okay, another question, great.
Hi, Eric Gatlin from GE Aviation. I'd like your guys' perspective on inspection. So as we scale larger and larger, the inspection technology, at some point you hit the limits of conventional inspection using CT or X-ray or our conventional methods, and even the surface roughness of parts don't lend themselves well to FPI and other traditional methods. What do you guys see as the next 5 years of inspection technology with methods that were tried and true today versus in situ monitoring or machine monitoring?
Well, everybody's looking. So yes, I think that the inspection technology will catch up, and I think we will see some step changes of things that we don't see today. In my earlier life, I worked in an inspection company for oil and gas pipelines, measuring metal by X-ray and some EMAT technology, which hasn't been there. And I do think that there will be much more newer, smarter measuring technologies that we can see through metals, because you need to see three-dimensional, you need to scan that. We always need final inspection somehow, just for get that final quality assurance. Now, we want to get the process stabilized that we can then have not 100% testing, but still random testing, but for aviation or so. So I do expect, and I do demand from the industry of the inspection to see some step changes also there, which not yet has fully happened. In Z2, we fully believe in to get as much data. There the big data and the digital twin comes to see as much data as possible in the build process to predict the end outcome. So we firmly believe in this monitoring of this. We do know that we don't yet have all the science ready for it, so we need to rely on the end testing, but it will load more into the in-process monitoring.
Yeah. And I agree, Florian. I think that the technology is going to come along. It's going to be pulled in to help in the additive manufacturing space. It may not be there today like we want it to be there, but I think there'll be new technologies developed. Do I know specifically what they are? I do not, but I hope it comes along quickly, because it is really important.
Yeah, so someone asked about, I think you asked about in-process monitoring. One of the things for, at least for the metals, there's a considerable amount of residual stress built into the parts. And that actually can be used as a way to monitor the process. So you can actually look at what that stress is in the parts as built. Now, you're going to want to stress relieve that in your machine and everything else, but as built, that's actually a pretty strong indicator that your process has been consistent, and you can make those as sensitive as you want. It's almost like a built-in strain gauge, if you will.
Another question?
Hi, I'm Rhonda Barnett. I'm the chair of Canadian Manufacturers. I'm just interested in your crystal ball. Oh. So as we move towards mass adaptation of the additive technologies, where do you see global supply chains going with major manufacturers? Do you see this, that our supply chains will migrate to the technologies, or are these technologies going to land on the big manufacturers' floors primarily?
So make sure I can clarify. So will the supply chain to the large OEMs be forced or want to see or be jumping in because of opportunity to supply to the major OEMs like the GEs, let's say, or will the GEs of the world, if you will, internalize the manufacturing? Okay, fair.
So I think Proto Labs has a little bit different mission than maybe some, but we view what we're trying to do as be like what cloud computing is to software startups, so that we can variabilize the capacity that anyone needs. So we'll have 160 different printers right now and some 500 mills for producing parts. So we view it as, here's a way to share capacity, and whether that means an OEM runs that themselves or whether there's some other way to share capacity, it feels like additive naturally allows itself to be used as a shared capacity, and then that can be localized as needed. There's really no reason for a lot of companies to run the manufacturing and a detailed supply chain and planning if they can have parts delivered when they want on demand, and then they can focus on the development and validation and integration and testing and serving customers. It's a switch in mindset. I think that's where OEMs know their market and their customers. That's the biggest value for them. The manufacturing side, I think, could get decentralized, like cloud computing has taken over for a lot of software companies.
Yeah, I mean, adding on this, I would answer it from two perspectives. Like, one is happening on the OEM and its supply chain. What we currently see is that every OEM on the planet wants to do some additive just to understand the process technology. They say, I need to understand what's going on because otherwise I'm relying on somebody like the three guys sitting on stage or GE to tell me what's possible, and then I cannot even spec it anymore. And that makes a lot of sense. If you cannot spec it anymore, then you're totally reliant on your supply base, and you don't want to be in that position. What we haven't seen is that the big OEMs, because of this, say, now I want to insource all the production. They still don't like assets. They still want to be flexible. They still like supply chains to compete with each other. They still want to have this. So we don't see this really moving. Some of the very sensitive stuff we see that people, but that's not different because of the technology. And as the technology will spread out, you don't only start with the crown jewels, you will also have the more standard components. So we see the split between the OEMs and its supply chain to stay the same. The second question then is obviously that's relevant for us, and you are coming as a traditional, so that's, are there new guys like us taking share of existing supply chains, or is the existing supply chain picking up? My answer to this, or I mean, obviously I have to believe that new guys will be successful. And we do see this because it needs a lot of dedication, and you need to move fast and you need to go into it. And we see it that a lot of big companies want to work with young companies like us, young in the field of making aerospace parts, although Oerlikon does make a serious double-digit million with traditional aerospace parts, which nobody knows, but we do. Some traditional manufacturers will pick it up if they really move fast, if they get it right. Others are slower. So you will have new players who are fast, and they will take a prominent share, and others who maybe think, that's too late. And the surfing example, if they miss the wave, then, so I think you will see a change in the supply chain of the guys who move fast and take it serious, and the others.
I agree.
That we might take. However, I need to add one sentence. If we talk about this wave, if we get 2% of traditional manufacturing, right, we're all super rich. So like super rich. If we get 5% of all manufacturing, we are heroes of the planet. So there's still 95% of non-additive stuff. If we talk about the wave and the revolution, just to put things into perspective, I don't even know where we're today per
0.00.
Whatever.
0.03%.
Just to put it a bit in perspective, like not like whole supply chains will go out of business and stuff. There's still 95%.
Yeah.
I agree, Florian. Yeah, you're spot on. I think the OEMs are figuring out how much they want to own, how much they don't want to own, how much they can outsource. It depends on what suppliers come up and say, hey, I'll make that part for you. You don't need to invest the capital. I'll manage it just like they do today. And that'll evolve over time, especially as the capital investment goes down. I think early on when the capital investment is high, it's probably going to be the OEMs or the very large supplier base that's going to be in making those investments. Of course, they'll see the benefit in the end, but as it matures, just like manufacturing has matured over time, there's a lot of suppliers that are going to step up. Now, where they're going to be, again, if the cost is down, cost of labor isn't really there. It's all about the machine time and the material costs. That can be done anywhere then. There is no low-cost labor that really is a big factor. So that does change the global supply chain and where parts might come in from.
Yeah, I think it's a great question, and if I had to, if I were to throw in my 2 cents on the crystal ball, I totally agree with Florian. And 5% would be a very large number, but if we're right now 0.03, 0.04, 0.05% of total global manufacturing output, which is roughly 17 trillion, and you look and say our industry today is a 10 or 12 billion dollar industry, I think in 10 years it's fair to say we'll probably be $100 billion. So great, but that's a lot of cash. And even large companies have other priorities outside of additive. I try to convince otherwise, but that's all right. So what ends up happening is at some point, a large corporation will take probably the most sensitive items from an intellectual property standpoint and hold those closer, but they will begin to look for their supply chains on the outside. And we haven't hit that critical mass quite yet, but I think it's coming as all these other things happen. Material characterizations, and as designers change their way of thinking and design differently, I think all that'll happen. So we have another question back here, and then another one up front.
Hi, I'm David Caputo with Rift Valley Equity Partners. My question relates specifically to your production of parts for aerospace customers. And what I'm wondering is, of the opportunities that you're seeing today, what proportion of those opportunities would you say represent requalifications of parts that are currently being produced using existing traditional manufacturing technologies, forging, casting, machining from block or otherwise? And what proportion would you say represent new parts that are being designed for the first time, specifically with 3D printing in mind? And then secondly, following on that, of the requalification opportunities that you're seeing today, what would you say the characteristics of those parts are, and whether there are characteristics in terms of the section of the aircraft that you're seeing most commonly, or just specific characteristics of the parts themselves, geometry, metal, or otherwise, that make these attractive, candidates for requalification, and how do you see that changing over time?
Good. That's a complex question that probably best is to ask an aerospace OEM. What we see, I mean, I cannot disclose the roadmaps that we see, frankly speaking. We see three use cases today. One is what I think Kim Smith mentioned earlier on, buy-to-fly ratio to get this done. This is a good use case. You can save titanium, you just redesign it, you don't need to cut it away, you save 90% of scrap. You see a lot of those components in the mainframe area, where it's an easy business case. You just save the material. It's from an engineering point pretty unexciting. Yeah. It's not like organic design and stuff like that.
That's almost near net shape is what they're doing.
Exactly.
For the
near net shape.
Parts that are being redone. So they're parts that can be machined, and they're going to requalify it in near net shape to save on expensive materials.
But it's good because you save money, your controller is happy, you qualify the process, and everybody...
And you qualify the part, and that's what we see is a lot of people trying to qualify parts for that, but I don't think they, at least on the laser-based systems, I haven't seen any that have come up as a cost winner yet.
No. Well, we have some you have.
They haven't been designed for it.
The future will be you redesign the part.
Yes.
And that will be, I cannot give you a percentage today. That's still small because GE is leading of really taking a crank at, let me redesign a fuel nozzle, because don't forget what that means. You cut the bridges, which, by the way, you have to do. Otherwise, you always have a way back. So if you cut the bridges, you can only do it with additive, then you make a leapfrog. The future will be fully, I don't know if it's 100%, but it will be close to this, that you redesign things, which you have these 855 to 12. So the majority will be fully redesigned, even the whole system, because then additive plays its strengths. Then you don't need to compare apples with apples in every single gram. Then I can charge a bit more because it has better performance. You calculate supply chain cost into it. What Jason said, not 60,000 miles traveling through orbit. Then your business case becomes true. So the future will be near 100% redesigned parts or even full systems in aerospace, but I would argue all over the place to really use the full potential of additive. But by this, I already described the time it takes, because if Greg comes with an idea to redesign something, we talk about a new engine program. And you're GE Aviation, right? Let me make a new engine program. Let's start tomorrow. Launch in 19. No, that's BS, we know this. So there you describe the timelines, what it takes. So you talk generation of machine, of systems, and then it gets interesting.
Yep.
I don't know if that answers the question.
At least the first part, I think. Paul, did you want to jump in on that?
Yeah, so we've been involved mostly in the aerospace area as designing for additive. People have been coming to us about doing replacement parts or to build parts to take care of obsolete aircraft components. Some of the aircraft in the Air Force, for instance, are 50 years old and designs don't exist, tooling don't exist. And then they're really forced to look at, okay, what's the most efficient way? Because it's not made with the same process. So all the validation work, it doesn't matter. It's irrelevant. Tooling's gone. All the initial studies are done. So then that opens up the door then for using additive, because they only maybe need 100 parts total to service the aircraft fleet for another 20 years. then that's a motivating factor, which then they'll start looking at, okay, what can you do for additive? And of course, you got to do a validation and show equivalency and performance parameters and material properties, but that's details. But then there's a lot of interest and motivation. So it kind of really depends on what the end product is and how much flexibility there is to really adapt that.
So I hate to do this because this has been some great conversation. We're about at a minute here, and I need to end this on time. So what I'd love to do is just get about a 15-second final thoughts for you guys about all the big codes, all the small codes, all the medium codes out there. You know, if they want to jump in, 15 seconds, recommendations.
I'll try to be really quick. Focus on design. Build your design champions. I wouldn't go into the hardware and all of that. That is bright and shiny and fun to look at, but stick with the design. That's where the value is, and let people go work on designs that can attack performance, not just as a cost. Don't spend your time trying to replace existing parts. It's kind of a fool's errand, in my opinion.
Great.
So I would say additive is the fundamental tool for the future. It brings the digital world into the real world. Early on I said it brings the cloud to earth, because everything in the cloud is great, but having physical stuff here is really great. For me, I like the iceberg picture, and we are, I think, the pioneers of it. We are drilling to the bottom of the iceberg, and I'd like to take as many of you on the journey to drill to the bottom of this iceberg and to really leverage the full potential.
Yeah, so for us, the additive piece for us with our customers is really about the value. So it does require having a lot of design, as Rich said, and we're pushing really hard in that area, and that is a differentiator. It's great to have a machine that's easy, anyone can get that and push a button, feed in CAD data, but you've really got to design it, and you've got to make sure it's going to be successful when you do that, and that's the upfront design. And that's really key, I think, for anyone who wants to get into that and expand into that. You got to have really good design, and really there's a shortfall today in the tools to support that design effort. To take your geometry and actually know whether it's going to build successfully on the machine. And we're evaluating a lot of different tools that are out there, and we haven't found the tool yet that's going to service all of our needs. Each one's got its own benefits, and feeding that back into the math data and the solid model data is really key, and making that process efficient so that we're designing it and then adapting it for the additive process and all the support structure. That element is right now an art and an engineering task that's challenging right now.
Great. Well, listen, Paul and Florian and Rich, thank you so much. We are now a little bit over, but we've got about 14 or so minutes, 13 minutes until our chairman and CEO, John Flannery, will be here on the stage. So I would encourage everybody not to go too far. Please leave your stuff on your chairs, and that session will begin at 2 o'clock. But please join me in thanking the panelists for a great session.
Thank you.